Alright, my name is Michael Leggett, and today I'm going to be going over my CBIR program, content-based image retrieval. So first I'm going to go through a few slides, give you all an overview of what CBIR is, what it does, the steps to complete it, basically walking you through everything I did to complete my program for it, and then I'm going to show you all my code, kind of explain it a little bit. I got comments in there too, but I'm going to kind of explain a little bit and give y'all some background on exactly what I did to get my CBIR up and running, and then I'm going to run the program and show you the end results of all the pictures and everything. Alright. So, overview. CBIR stands for content-based image retrieval. CBIR is also known by it's also been known by two other types of names: QBIC and CBVIR. QBIC stands for query by image content, and then CBVIR stands for content-based visual information retrieval. So basically the same thing as CBIR, just different names and different ways of doing it, but you get the same end result, which is images that are similar to one another. So how CBIR works is, well, for the program we were given 100 images. So basically what it would do is program would scan through, well, in this case, program would scan through the 100 images we were given. And it analyzes them and then kind of sorts them based on their texture, shape, and colors. So, I mean, if images are red, white, blue, if they have circles, squares, triangles, any type of textures they have in them, basically sort them based on that. And here I said sort them based on that instead of metadata, because for other types of image retrieval, they may like find similar images based on their descriptions or keywords or tags that's in them. Kind of like how Google works. You look up whatever, and then it'll bring a bunch of similar images. Like if I was to look up bananas, it would bring up a bunch of similar images based on the keywords and descriptions I used and typed in. So instead, this uses textures, and this looks at the image itself and uses text, shapes, and colors in the image to bring up similar images. So like I said, the program will run through all the images that you give it or that we got, and it will show a collection of all the photos that are similar to one another. So there's 6 basic steps, well, more like 5 steps to completing content-based image retrieval. Step 1 is represent the image using a histogram. So basically we represent the images that we're using. We basically represent those using a 6-color, I believe, yeah, a 6-color histogram. And then step 2 would be measuring the distance between those images. To do that, we use Euclidean distance. That's what we use to measure the distance between the vectors of the image. So that's part of determining that basically determines what images are similar to one another. The distance between the vectors. And then the implementing CBIR framework, that's just more of a overview of everything. That's not really a step per se. But step 4 would be placing the images in order based on the distance between them. So like I said before, we find the distances between their vectors. So the closer the vectors are the closer the distance between the vectors in the image, the more similar they are. So images whose vectors are smaller, they're going to be more similar to the image that we chose, like similar to the original image that we chose. Basically, so after that, it would return. We have our program set to return the top 20 most similar images, but I guess you could kind of edit your program to show the top 30, top 40, top 10. But we have ours to return the top 20. So once it returns those top 20 images, it'll just step 6, and the final step is to display them for you. So like I said, step 1 is representing the image with a histogram. So histograms are a pretty common thing in CBIR, or one of the common features in CBIR. So for step 1, we use a 6-bit color-coded histogram to represent the image we choose. And we're going to be finding 20 images that are similar to the image that we chose. So, after the histogram is filled, it's extracted with each one of the images that's in the data set. And then once those images are extracted, they're stored in a matrix that consists of 100 rows and 64 columns. And the rows represent the images. That's what the images are contained in. Like I said, step 2 was measuring the distance between them. And this is what determines this is how the program determines like what images are most similar to one another. Like I said, the images that have a smaller distance between their vectors, those are the ones that are considered most similar to our original image that we chose. And right here at the bottom, you see the distance formula that we used to complete that. Like I said, the program is based on colors, shapes, and textures. And so instead of descriptions, keywords, and whatnot, we use colors that are in there, the shapes, the textures, to determine which images are most similar to one another. Step 3, ordering the images. So after the distances are collected between all of the images, we order them. So from the images that got the least amount of distance between their vectors, those are given a lower ranking, and then the images that have the most distance between their vectors, those are given a higher ranking. So the ones with the higher ranking would be the ones that are least similar to our image that we selected, and then the ones with the lower ranking will be most similar. So in this case, we would basically get displayed the 20 images that have the lowest ranking, because they have the least amount of distance between their vectors, which makes them most similar to the image that we chose. So returning the images, like I said, this is on the right over here. This is the code for all the way at the bottom where you see top 20 IDX equals IDX 1 through 20. That's basically showing the top 20 images that are most similar to our original image that we chose. They're showing the 20 most similar images. So, and then displaying them, this right here is a screenshot of the code where it displays the 20 most similar images. The image at the very top is the original image that we chose, and then the 20 images below it are the images that are most similar to it. You'll see this when I run it in MATLAB. It comes up as a separate little figure window, and this would be the last step of content-based image retrieval. There's a question slide. I guess it was for if we actually had live presentations in person, but since we didn't, I don't really need that. Take you out. Alright, so here's the code for everything. I'm gonna go through. These are the 5 files: the get distance, CBIR, create the database, DB, getting the histogram counts, and RGB26CC fast. So I'm gonna walk you through all 5 of these files and then show you the end result. So for the RGB26CC fast, Well, as you can see, it uses the bit shift and polynomial method to convert our image into a 6-bit color histogram. So right here, this code right here, this is basically the first step in that, which is applying the bit shift. And then right here, step 2 would be the using the polynomial. Like I said earlier before, how we use the bit shift and polynomial methods. This code right here would be the bit shift method, and then this code over here would be the polynomial method, which converts the base 4 value to a 10 value. And then over here we have the get his counts function. So there's multiple parts to getting the histogram counts in each of the pictures, but as you see, this code right here creates the counters. This code will calculate the bin width of all of our pictures. We also have to count the lower bound and upper bound. That's two pretty important parts of getting the histogram counts. This code right here will count all the pixels that's in the bin that was created up here. This code right here will count all those pixels. Moving on to the create database. This is where our program kind of is searching through our directories, trying to find. Up here you see our directories. Let me see if I can go back. My computer is kind of slow, but yeah, you can see how we have our source code directory, data, meta, and import, which is where all of our pictures are at. So yeah, so right here you see import path. That's basically going to our data directory and then going to the import and reading all 100 pictures that are in our import directory over here. And basically this is creating our database, our 100x64, our 100 rows by 64 columns database to store all the pictures. This is what the create database is doing. And the get distance, like I had said before, we're getting the distance between the vectors in the photo. The lower the distance between the vectors, the more similar they are to our original photo. And our equation, these are the vectors P and Q, and our equation for determining that. This is our actual CBIR program. I'm running out of time here, so I'm going to try to hurry up through this, but you see our import path where we're reading through our directories. You see the get distance to determine the distance between the vectors. Right here, top 20, like I said earlier, shows you the top 20 images. And down here is how we end up displaying the top 20 images in another window. So I'm going to hurry up and run this real quick. My computer is kind of slow. Like I said, my computer is slow, but yeah, here we go. It's going to bring up all 100 images, and then you choose whatever image you want. I'm going to just choose that. And alright, I'm probably going to run out of time, but my computer's slow. But once you click the image that you want, it'll bring up the 20 most similar images to it.